Hello everyone, I am AHMED ALBAHNASAWI, a research fellow in the Environmental Engineering Department at KIBZ Technical University. I am going to share with you my thoughts about the interesting topic value added products from bio-waste. The alarming increase in the global population has not only incremented the demand for energy, but also increased our consumption of various resources. The increased consumption pattern has led to the increase of solid waste generation from 1.3 billion tons in 2012 to 2.2 billion tons in 2025. The cost associated with the uncollected waste is 47 times higher than the cost needed to treat the waste. In addition, improper waste disposal techniques have resulted in emission of 1.6 billion tons of CO2 in 2016. Effective waste treatment strategy enhance the environment, health, and economy. However, more than two-thirds of the waste generated end up in landfills and dump yards. Third, waste treatment have positive effect on the environment, but during the treatment, certain harmful chemicals could be released. For example, incineration releases dioxins which pollutes the atmosphere. Food and garden waste account for half of the solid waste, while recyclable and plastic account to 26% and 12% respectively. Many municipalities have reported that up to 50% costs incurred could be recovered, which questions the visibility and sustainability of the technology being proposed. Biowaste management strategies include thermal conversation, gasification, pyrolysis, purification, anaerobic digestion, and compositing process. Incineration is the oxidative composition reaction at high temperature under aerobic conditions with objective of volume reduction and energy recovery. The end products are composition gas, solid and ash, which are capable to applied as a material for building and used as heat resource. Incineration also incorporates composition of materials leading to the production of heat energy that can be used to produce electricity via turbines. This technology is more preferred for energy recovery from non-biodegradable sources having low moisture content. Literature review suggested that approximately 500 kilowatts of electricity can be produced by the incineration of around 1 ton of waste. It helps in the minimization of large volume of waste and their disposal at landfills. This technology also helps to reduce methane, which is the undesired product of open disposal of municipal solid waste. However, the major limitation of incineration is the production of toxic metal and particulate solid particles, dioxins and furans, which are supposed to be detrimental for the environment. Incineration is more pronounced for some waste such as clinical and biomedical waste, where the heat energy can destroy pathogens and their toxicity. Gasification. During gasification, the biowaste is converted to produce gas, which with limited supply of air through drying, pyrolysis, composition, and reduction simultaneously. In this process, the producer gas can use for value-added chemicals and also use as a fuel. The producer gas is a mixture of carbon monoxide, hydrogen, carbon dioxide, and methane. The product from gasification depends on the type of feedstock, gasifier design, pressure and temperature, and gasification agent. The product, either solid or gas phase, the untreated char has more than 76% of carbon content, means that it can use directly in industry application. The producer gas can be used for power generation, chemical production. The producer gas can be directly connected to the boiler or steam turbine, also used in IC engine and gas turbines for power generation. Pyrolysis efficiently converts organic waste into usable products such as bio-oil, biochar, and gases. Pyrolysis is usually carried out in an oxygen-depleted environment at a high temperature, and the product depends on the process and reaction conditions such as residence time and heat transfer rate. The main products of pyrolysis biochar used for several applications, which is used for making catalyst, heating, and wastewater treatment application. The liquid bioproducts from pyrolysis were bio-oil. It's a mixture of water and chemical component. Purification, the thermal upgradation of biomass into further homogeneous product, which is designed over volatilization to produce denser energy products known as briquettes or purified pellets, having comparable properties to coal. This type of energy is useful for more thermochemical conversion. This technology is also known as terrified process method. This thermochemical approach is stretched between 200 and 300 Celsius temperature range at low heating and inert atmosphere. Anaerobic digestion. Anaerobic digestion is a treatment of complex organic compound into methane and other gases. The key parameters such as loading rate, temperature, retention time, pH, and carbon to nitrogen ratio are ensuring the process stability. The main products of an aerobic digestion process are biogas and digestate. The methane is the major part of biogas. It can use directly for thermal application and used for combined heat and power for electricity generation. The biogas refinery further to use for gas-driven engine and fuel cell application. In recent days, hydrogen has been separated from biomethane and used as a high heating value fuel. The digestate contains nitrogen, which can be used as a nutrient and organic fertilizer for agriculture. In addition, the process optimization and pre-treatments are used to enhance the anaerobic degradability and upgrading the value-added product. Aerobic compositing process. Aerobic compositing is a biological treatment of organic waste into fertilizer in controlled medium, which happens in 3 phases of degradation, transformation, and synthesis. Multi-stage process and feedstock pre-treatments are helping to reduce the process time. Compared to anaerobic conditions, the aerobic are suitable for compositing due to high disintegration rate and bacterial growth. The output from compositing is soil with crumbly texture, dark brown cake, and earthy smell besides leachate and carbon dioxide. The quality of the final composite depends on the physical and biological operating condition and substrates. The essential factors affecting compositing mainly include raw materials, temperature, moisture, oxygen, and carbon to nitrogen ratio. Temperature is important element to thrive the effective process. The pathogens and parasites were effectively eliminated during 50 temperature while microorganisms still active. The composite is rich in nutrients like nitrogen, potassium, and phosphorus, and variety of minerals, which is beneficial microorganisms for plant growth. Composite can be used to enrich the soils, and it can be utilized to convert landfills, remediate, and restore land. Biorefinery concept. Currently, the biorefinery recycling organic waste to valuable product through multi-biotechnology process with the objective of bioeconomy. Biorefinery emerged as a sustainable approach and recognized promising transformation platform to converging biomass to bioproduct, which designed to improve economic potential and achieve circular bioeconomy by integrating various technology. Integrated biorefining concepts into bio-waste management is promising for circular bioeconomy. Thank you for listening. Any question?